Alright, I'm going to apologize ahead of time. These notes are long, so let's just get started. We're going to keep working with trigonometric equations, and so for this first two examples, we're determining if pi over 4 and pi over 6 are solutions to 2 sine theta minus 1 equals 0. And how you do that is just plug in the radian for theta and see if it works. So we're going to check it out. So 2 sine pi over 4 minus 1 equals 0. We're going to check that. And so the sine of pi over 4 is square root 2 over 2 minus 1 equals 0. 2 times square root 2 over 2 is square root 2 minus 1 equals 0. And I'm going to add 1 to both sides, and I get square root 2 equals 1. And I know that's not true, so therefore pi over 4 is not a solution. Alright, let's try pi over 6. So 2 sine pi over 6 minus 1 equals 0, question mark. Sine of pi over 6 is 1/2, minus 1 equals 0. 2 times 1/2 is 1. 1 minus 1 is 0. 0 equals 0. Check. So therefore, pi over 6 is a solution. And you can tell this on a graph just because those are your x-intercepts on your graph. Okay. And you can represent all those solutions by adding 2 pi k, because every 2 pi for sine is your period, and you get the same solution. Alright, so for this first one, we're going to solve the equation and give a general formula for the solutions and list 8 of those solutions. So the first thing is we have the cosine theta equals 1/2. So which angles have cosine equals 1/2? So when does cosine equal 1/2? And if we look at our unit circle, we get that that's at theta equals pi over 3 and 5 pi over 3. And again, if we keep adding 2 pi to these, we would keep getting to that spot on the unit circle, which is the solution of cosine theta equaling 1/2. So to write our general formulas, we would say theta equals pi over 3 plus 2 pi k, and theta equals 5 pi over 3 plus 2 pi k, where k is an integer. Now we're going to list 8 of those solutions. So we have pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, 13 pi over 3, 17 pi over 3, 19 pi over 3, and 23 pi over 3. And you just find those by adding 2 pi over and over and over again to either pi over 3 and 5 pi over 3. Alright, next, solves 2 sine theta minus 1 square root 3 equals 0. So we're going to solve for sine theta. So I'm going to start by adding over the square root 3 to both sides. So 2 sine theta equals square root 3. I'm going to divide by 2. So sine theta equals square root 3 over 2. And I need to know, and this was supposed to be a plus here, so it's actually a minus. Minus, minus, and then it'll be negative. Minus, 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 so negative root 3 over 2. So when does sine equal negative root 3 over 2? That's at theta equals 4 pi over 3 and 5 pi over 3. And you get those from your unit circle. And that's it. All right, next is sine 2 theta equals 1/2. So we want to know, when does sine equal 1/2? And that's at pi over 6 and 5 pi over 6. So we know in that parentheses that needs to equal 5 pi over 6 and pi over 6. So we're going to say 2 theta equals pi over 6 and 2 theta equals 5 pi over 6. So when I divide by 2 on both sides, I get theta equals pi over 12 and theta equals 5 pi over 12. So each of these, since the inside was 2 theta, that means our period change is to pi, which means there would be 2 complete full graphs in the cycle from 0 to 2 pi. And you can figure that out by using our period equations from last chapter and graphing this. So there's going to be 4 solutions if we ended up having a graph of sine. Here's 2 pi, here's pi. It would end up being like this, 2 of them. So all of these, 1, 2, 3, 4 solutions, excluding 0. So those solutions are pi over 6, theta equals 5 pi over 6, theta equals pi over 12, theta equals 5 pi over 12. And then again, we think of that adding each time. And so 2 theta equals these from above. And so the period of sine is 2 pi, so plus 2 pi k. Because we knew the parentheses had to equal pi over 6 and 5 pi over 6. And then below, we just solved for theta. And so since we got rid of that 2, it'd be like we were dividing by 2 here. So now it's just plus pi k, plus pi k. And then remember, k is an integer. All right. Moving on, we have solve for tan theta minus pi over 2 equals 1. So we want to know, when does tangent equal 1? Between 0 and 2 pi, and that's at pi over 4 and 5 pi over 4. And so we're going to set these equal to the inside of the parentheses. So theta minus pi over 2 equals pi over 4. We're going to add this to both sides. So add pi over 2, add pi over 2, which is also 2 pi over 4. So theta equals 3 pi over 4. And then we have theta minus pi over 2 equals 5 pi over 4. We're going to add the pi over 2 to both sides. We get theta equals 7 pi over 4. So making our equations, remember the period for tangent is pi. So theta equals 3 pi over 4 plus pi k. And theta equals 7 pi over 4 plus pi k. But since the tangent period is pi, going from 3 pi over 4 to 7 pi over 4, these are our 2 different solutions there. Okay. Next, we have to use a calculator to solve for tan theta equals -2. So to solve for theta, we're going to take the tan inverse on both sides. So we have tan inverse of -2. Remember, in your calculator, you use radians, and we get theta equals -1.11. to get two answers, because right now we're at negative 1.11, which isn't in our restriction of being between 0 and 2 pi, and we want two solutions. So we're going to add pi, and we're going to add 2 pi to get those two answers to negative 1.11. So negative 1.11 plus pi and negative 1.11 plus 2 pi. This equals 5.17 and 2.03. So theta equals 2.03 and 5.17. Okay. Next we have solve for 2 sine squared theta minus 3 sine theta plus 1 equals 0. And we're going to do this like a quadratic. You can go in and replace x for sine. So we can say sine theta equals x. And we can do 2x squared minus 3x plus 1 equals 0. We can factor this to be 2x minus 1 times x minus 1 equals 0. And then we're going to replace the sine back in now. So 2 sine theta minus 1 equals 0. And sine theta minus 1 equals 0. And we're going to solve for sine theta on both of these. So 2 sine theta equals 1 divided by 2. Sine theta equals 1/2. And then sine theta equals 1. So where on the unit circle does sine theta equal 1/2? And where does it equal 1? And it equals 1/2 at theta equals pi over 6 and 5 pi over 6. And then sine theta equals 1 at pi over 2. Okay, going into our identities, these are things that you're going to want to remember. So these three are important, and then here's the next two. So we're just going back to these are called our Pythagorean identities, and you just get these using the Pythagorean theorem. And so looking at this first one we were given of our identity, I'm going to divide it all by cosine squared theta. And that's how I get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. And this sine squared theta over cosine squared theta is tan squared theta. Cosine divided by cosine is 1. And then 1 over cosine is secant. So by doing that, that's how you get that second one. And then by doing divided by sine, that's how you would get the third one. Okay, so we're going to use these identities in solving these last three problems. So for the first one, we have 3 cosine theta plus 3 equals 2 sine squared theta. So we have cosine and sine. We only want to have one trig function. So we are going to use the sine squared theta plus cosine squared theta equals 1. And we're going to solve for sine squared theta by subtracting on both sides cosine squared theta. And we get sine squared theta equals 1 minus cosine squared theta. So I can plug this in for that sine squared theta in the problem. So I get 3 cosine theta plus 3 equals 2 times 1 minus cosine squared theta. And if I distribute, I get 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. I'm going to put this all on one side and set it equal to 0. And I get 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Again, I'm going to go ahead and factor, and I end up getting 2 cosine theta plus 1 times cosine theta plus 1 equals 0. Set both equal to 0. 2 cosine theta plus 1 equals 0. And cosine theta plus 1 equals 0. So I need to find when cosine theta equals negative 1/2 and when cosine theta equals negative 1. And that's when theta equals 2 pi over 3, 4 pi over 3, and pi. Next, we have cosine squared theta plus sine theta equals 2. We're going to use that same identity from last time and solve for cosine this time. So we have sine squared theta plus cosine squared theta equals 1. Subtract sine squared theta from both sides. And I get cosine squared theta equals 1 minus sine squared theta. Again, I'm going to plug this in for here, so I'm all in terms of sine. So 1 minus sine squared theta plus sine theta equals 2. Get it all on one side. So 0 equals sine squared theta minus sine theta plus 1. And then I'm going to look to factor this again. And then I know that this is not factorable. So this ends up being not factorable, which means there's no real solutions. So theta cannot equal 0 though. So not factorable. No solutions. Alright, last problem. We have to solve this in a calculator, and we're going to set up two different graphs. So we're going to graph y equals 5 sine x plus x and y equals 3. So if we go into our calculator and we put in 5 sine x plus x, and in our second one we have 3. We're going to plot function. Okay. 5 sine x plus x, 3 plot. We're going to go ahead and press menu, function, trace, and we get this point here, menu, function, intersection. Okay, so you're going to find all the points of intersection on this graph. So that first one was 0.52. The next one is 3.17. And the last one is 5.7. So those point of intersection is our solutions. So we get x equals 0.52, 3.18, and 5.